This is going to be an introduction to sampling in Modo. Now there's two separate kinds of sampling that I'm going to discuss. The first is anti-aliasing, and this involves things such as geometric edges and any surface-based shading such as texture maps and bump maps. The other kind of sampling is ray sampling, and this is where you fire rays. So this includes things such as global illumination and blurry reflections, soft shadows, area lights, and so on and so forth. Now these two kinds of sampling are totally separate from each other. You can control them independently of each other, so I'm going to discuss them separately. Now, a clever thing in Modo is that the geometric anti-aliasing is decoupled from the shading-based anti-aliasing. The geometric anti-aliasing is controlled by your global AA settings, and the shading-based anti-aliasing is controlled by something called the shading rate. The shading rate acts as a limit on how many samples can be fired on the surface of any one shader. This means that you can raise your global anti-aliasing extremely high without really affecting your render times too adversely, because the shading rate will limit how many AA samples are fired on shaders that have a very coarse shading rate. So to demonstrate this, I've set up this very simple scene and rendered it using the default values. You can see that it rendered in just 16 seconds. So if we look at the top of the shader tree, there's a base shader, and this has a shading rate of 1 pixel. Now what this means is that wherever the render engine is going to find this shading rate, and there's no geometric edges to deal with, it's only going to fire one single anti-aliasing sample for every pixel. And this happens no matter what the global anti-aliasing setting is set to. So if I go to my render item and look at the global anti-aliasing, it's currently set at 8 samples per pixel. If I was to increase this to 32 samples per pixel, which is 4 times greater, my render is not going to take 4 times longer. And this is thanks to the shading rate in the base shader, which is limiting how many samples are fired on the surfaces. So the increased sampling that I've just set here is only going to occur at the geometric edges. So I'm going to put this to the test by firing off a render. And if our initial render took 16 seconds, we'd expect a render that was 4 times longer to take just over a minute. But you'll see that this is not going to be the case here at all, because our render time is only going to increase by a very small amount. And this is because all of the extra sampling that we've just set is only going to happen in very specific places along the geometric edges of these objects. You can see that our render has only gone up by 4 seconds. It's not even doubled. It's not even 50% more. It's really only a tiny bit more. And that's thanks to the shading rate of 1, which is acting as a brake, if you like, on the global anti-aliasing. Now, one question you should be asking yourselves at this point is, if we're only firing one single anti-aliasing sample for every pixel on these surfaces, how come there's no jagged edges? In fact, if I zoom in, you can see that there's definitely some kind of anti-aliasing going on here, but it's not set in the shading rate. So what exactly is it? Now this is controlled by the refinement shading. Refinement shading in Modo serves one very specific purpose, which is to deal with high contrast edges, especially on shaders that have a coarse shading rate such as 1 or 0.5. So if I return to the scene, I'll explain how this is set up. In your main render item, under Settings, just below where you set the global anti-aliasing, you'll find Refinement Shading Rate and Refinement Threshold. So let's talk about the refinement threshold first. What this is essentially contrast. So whenever the render engine renders a bucket, it will then have a look at all the pixels that it's rendered. And if it finds 2 neighboring pixels whose contrast exceeds 10%, it will basically throw them away and re-render them using the refinement shading rate instead of the shading rate that is set in your base shader. Now in this case, I'm using the default values, which means that my refinement shading rate is set at 0.25 pixels, which means that whenever the refinement shading rate kicks in, it will be firing 16 samples for every pixel instead of just 1 as set in the base shader. So you can see how this is very useful for cleaning up high contrast areas that would otherwise be very jagged when you're using this very coarse shading rate. So to demonstrate exactly what the refinement shading does, I'm going to set the refinement threshold to 100%, which basically disables it because it's not possible to have a range of contrast greater than 100%. And I'm going to fire off a test render, and we'll compare it with the previous render just to see exactly which pixels were refined and where we had the extra anti-aliasing. Now this render is obviously going to be a little bit quicker than the previous one because we're doing a lot less sampling because there's no refinement shading going on. And you can see it has shaved a couple of seconds off our render. And if I zoom in, you can see that we've now got jagged edges pretty much everywhere where there's high contrast. So on the edges of this grid texture, inside these sharp reflections, we've lost all the anti-aliasing because that's exactly what the refinement shading was doing. So you can see that in situations where we're using very simple shaders like we are here, you can use a very coarse shading rate and then just rely on the refinement shading to clean up any high contrast problem areas for you. However, if you're dealing with more complex shaders that are costly to calculate, I don't recommend trying to use refinement shading to solve noise problems in those cases. So this would be when you've got maybe a material that has a very fine bump map that's causing a bit of noise, or you've got blurry reflections, that kind of thing. And the reason that refinement shading is a bad idea in those cases is that essentially it acts as a second pass. So if a bucket is rendering, what will happen is that the entire bucket will be rendered, and then the render engine will go through and compare neighboring pixels to see if any of them have more contrast than is permitted by the refinement threshold, and then it will basically throw away the first set of renders and re-render. And if you've got a material that's very costly to calculate, well, that is going to basically double or more your render times for no good reason. Now, when you've got very simple shaders, it's not a problem because the amount of time you've lost is negligible. In fact, you're gaining time rather than losing time simply because it allows you to use this very coarse shading rate everywhere else. But for complex shaders, you really don't want refinement shading to kick in. You want to control them with a custom shader on the item or material in question. So my recommendation when it comes to refinement shading is just to leave it at default value, never touch it, because in most cases it works just as designed. So now I've modified the scene and I've added this wood texture to this sphere on the right hand side, and this has got a very fine-grained bump map on it. And I've done a render already. You can see it's taken 26 seconds, but we've got a lot of noise where this bump map is applied, and that's because of the coarse shading rate that we're using in the scene. So here we need a finer shading rate, but what we don't want to do is apply this shading rate globally, because it will affect the entire image, and we don't want all the other shaders in the scene to be affected in the same way. So what we need to do is basically add a custom shader to this one material. So I'm going to select the material that has the bump map, and I'm going to add a shader to it. And I'm going to set the shading rate in that shader to 0.25, which, as I said earlier, is going to fire 16 samples for every pixel. Now, I'll discuss the actual rates in more detail later on, but this should do for now. The next thing I need to do is to grab this material and to drag it above the base shader so that it's not overridden by this shader here. And now this shader will take effect, so I'm going to fire a render. So the render is now complete, and I'm going to compare it with the previous render, and you can see that it is noticeably cleaner thanks to the finer shading rate that we're using on the material. But the other thing I want you to note is the increase in render time is really small. We've gone from 26.1 seconds to 29 seconds, and the reason that our render time has increased so little is essentially because we've targeted the extra samples exactly where we need them on this one particular material, and for the rest of the scene we're still using the very coarse shading rate. The next thing I like to talk about is the concept of a rate. So wherever you see a rate in Modo, be it shading rate or a displacement rate, etc., this is how I like to think of it. I like to imagine it a bit like a grid, which is a huge simplification, but it helps me to understand a little bit how it works. So what happens is Modo will consider a pixel, and where necessary, it will divide this pixel into a number of subpixels. So if we imagine that this white square on my screen is 1 pixel, if we set our shading rate at 1, well, we only get 1 sample per pixel. There are no divisions. However, if we set the shading rate to 0.5, what I like to imagine is this grid where basically the subpixel divisions happen at the halfway point, 0.5, on both axes in the X and the Y. So this divides our pixel into 4 subpixels, meaning that we get 4 samples for every pixel. So again, what I like to imagine is that when we reduce the shading rate, we're simply dividing this imaginary grid into finer and finer units. So if I was to set a shading rate of 0.25, what I imagine is this grid being divided every 0.25, every quarter point in the X and the Y, which gives us 4 units in the X and 4 units in the Y, meaning a total number of 16 samples. And we can carry on doing this. So imagine if we set 10 divisions each way, which is a shading rate of 0.1, well then we get 100 samples per pixel. Now obviously what I'm describing here is an abstraction. It isn't actually how the shading rate works. It's just a way of visualizing how many samples you're going to get when you set a certain value in the shading rate. And I find visualizing this grid really helps me understand that when I set a shading rate of 0.25, I'm going to get 16 samples per pixel. If I set my shading rate to 0.1, I'm going to get 100. If I was to set it to 0.01, I would get 1,000 samples per pixel. And as I said earlier, if you actually set your shading rate to 0, well then the concept of a shading rate is completely eliminated from the picture, and it's your global anti-aliasing which then controls how many samples are fired per pixel. So this brings me to the final piece of the puzzle, which is to explain that the shading rate and the global anti-aliasing work together. What I mean by this is, if we have a quick recap. So if we set our global AA to say 128, but we have a shading rate of 1 sample per pixel, what this means is wherever the render engine encounters a shader with a shading rate of 1 sample per pixel, as long as there's no refinement shading or geometric anti-aliasing to do, it's only ever going to fire 1 sample per pixel, no matter what the global AA is set to. Conversely, if we set a shading rate of 0.1, which means that potentially we could be firing 100 samples per pixel, this doesn't mean that we're always going to fire 100 samples per pixel, because the global anti-aliasing setting also acts as a maximum. So if you set your global AA to just 8 samples per pixel, then that means that even if your shading rate is 0.1, you're never going to fire more than 8 samples per pixel. So the value that you set in your shading rate always acts as a maximum value. So if you have a shading rate of 0.1, it means that you'll fire a maximum of 100 samples per pixel, but it doesn't mean that you will necessarily fire 100 samples per pixel, because it also depends what your global AA setting is set to. As you can see, the two settings work very closely together. And finally, if you set your shading rate to 0, that completely disables the shading rate, and it means that your global anti-aliasing now fully controls the sampling on your shader. So whatever value you set in your global anti-aliasing, be it 128, 256, etc., that is how many samples will be fired on every single pixel of your shader. So in some cases this is very useful, because if you don't want to limit the sampling with the shading rate, you simply set it to 0 and then control it with the global control. Two other aspects of rendering in Modo which are very heavily influenced by your global anti-aliasing settings are motion blur and depth of field. Now they both work very similarly, so I'm just going to look at depth of field in this case here. And I've rendered this scene with shallow depth of field, and I'm only using 32 anti-aliasing samples per pixel. So when I zoom in, just as you'd expect, it's very noisy. But what I need to do here is simply to raise the global anti-aliasing settings. The shading rate will have no effect on depth of field. Of course, it will affect surface shading, as we already know, but for depth of field alone, I just need to look at the global anti-aliasing settings. So what you should always do in situations like this when you're troubleshooting is define a render region. So I've already defined a render region, and now I'm going to return to my scene, and I'm going to gradually increase the global AA settings until I get a clean result. So I'm going to set it now to 256 samples per pixel, and I'll just pause the video while I do a test render. And with the render complete, if I zoom in on our render region and compare it with the previous render, I can see that it's definitely improved, but it's not completely clean yet. So I need to return to the scene and tweak my settings a little bit more. So I'll go to my settings again, and I'll increase the global anti-aliasing to 512 samples per pixel, and just pause the video while I do a test render. And with the render complete, I'm going to zoom in and compare it to the previous render. And this time, the improvement is very, very slight. And I'm at the second highest level of anti-aliasing that's available to me. So what can I do in order to clean up this shot? Well, there is one more option available to me. If I go back to my scene, I'll increase the global anti-aliasing to the maximum value of 1024 samples per pixel. But I know that this isn't going to be enough to clean up all the noise in the shot. So the next thing I need to do is to go to the frame settings and increase the number of frame passes. Now, this is a very costly setting because each frame pass will render the entire frame from start to finish. So if I increase the frame passes to 2, it's essentially going to render the frame twice. But what it's going to do is in between the 2 frame passes, it's going to slightly jitter the anti-aliasing noise, and also it's going to jitter the GI noise, any noise in hair. So it's very, very useful when you've run out of options to try and clean up noise. You can increase the number of frame passes, and this will help with all sorts of noise problems, including this particular anti-aliasing problem that I've got here. So I'm going to fire a test render, and I'll just pause the video while it's rendering. And with the render complete, if I zoom in and compare it to the previous render, I can see it's definitely cleaner. So for my purposes, I think I'm going to decide that this is clean enough. So I'm simply going to untick the render region and render the whole frame again. And with the render now complete, I'm going to zoom in and compare it to the very first render I made. And you can see the result is a lot cleaner. This is good enough to use in production now. The problem is the render time has increased dramatically. It's gone from the original 54 seconds to 18 minutes. So it's 18 times longer. And that's because I've been making changes to the global anti-aliasing settings, and that's been compounded by the fact that I've had to use 2 frame passes to get a clean result. So just bear in mind that doing depth of field natively is going to require a lot of anti-aliasing samples to get a clean result, and this means that you are probably going to encounter very long render times.